Good morning friends. Today we'll study what is orthogonal property of Lagurre polynomial. Now today we have to prove that integration 0 to infinity to the power minus x ln x lmx is equals to 0 if m is not equal to n and 1 if m is equal to n. Now by generating function of Lagurre polynomial we know that summation n equal to 0 to infinity t to the power n ln x is equals to 1 by 1 minus t e to the power minus tx upon 1 minus t, and summation m equal to 0 to infinity, here variable is s, so s to the power m lmx is equals to 1 upon 1 minus x e to the power minus sx upon 1 minus x. Now we'll multiply both these terms 1 and 2. On multiplying these we get summation n equal to 0 to infinity t to the power n ln x and m equal to 0 to infinity s to the power m lmx. So where the summation runs from 0 to infinity over n and m 0 to infinity ln x into lmx and t to the power n into s to the power m is equals to 1 by 1 minus t into 1 by 1 minus s e to the power minus tx upon 1 minus t and e to the power minus sx upon 1 minus s. Now we'll multiply both these sides by e to the power minus x, and the summation since runs from 0 to infinity for both m and n, so we'll take the single summation. Summation mn goes from 0 to infinity and we have multiplied both sides by e to the power minus x. So e to the power minus x e to the ln x lmx t to the power n sn is equals to e to the power minus x, and all the same terms will come down. 1 upon 1 minus t 1 minus s e to the power minus tx by 1 minus t and minus sx by 1 minus s. Now we'll take e to the power minus x common from all these terms and we'll see that we get e to the power x upon 1 minus e to the power t upon 1 minus t, e to the power s upon 1 minus s, and here we get 1 as e to the power minus x is taken from here common. So finally we get 1 upon 1 minus t 1 minus s e to the power minus x t upon 1 minus t s upon 1 minus s and plus 1. Now we will integrate the previous equation on integrating both sides. Integration 0 to infinity summation mn equal to 0 to infinity to the power minus x ln x lmx t to the power n s to the power m dx is equals to 0 to infinity 1 by 1 minus t 1 minus s e to the power minus x 1 upon 1 minus t plus 1 minus s plus 1. Now 1 by 1 minus t into 1 minus s will come out as a constant, and integration will be 0 to infinity e to the power minus x 1 upon 1 minus t plus 1 minus s plus 1 dx, and then we'll integrate it, and this will simply come as e to the power minus x, and the term which is multiplied with x will come to the denominator. You can do it by substitution method. So minus 1 by 1 minus t plus 1 by 1 minus s plus 1 will come to the denominator, and now we'll put upper value minus lower value. So this will be e to the power, so this minus in the denominator goes to the numerator, and upon t by 1 minus t plus s by 1 minus s plus 1 will come as it is. And now we'll put the value infinity and 0 over this. So when we'll put infinity e to the power minus infinity, and this is in the product form, so this can be written as power in the form of power of e to the power minus x. So e to the power minus infinity will become 0. As I have written here, e to the power minus infinity will become 0. So anything to the power 0 is again 0. So this will come as 0, and the second is the lower limit is 0. When we'll put e to the power 0 is 1, and 1 raised to the power anything is again 1. So e to the power minus infinity will become 0. So above powers are not written, and e to the power 0, e to the power minus infinity is 0, and e to the power 0 is 1. So this is simply 0 minus 1, and the terms in the denominator are calculated. We'll take the LCM 1 minus t 1 minus s, and this becomes t into 1 minus s, s into 1 minus t plus 1 minus t into 1 minus s. Now this minus will become plus, and 1 minus t and 1 minus s will cancel out. 1 minus t 1 minus s will cancel out, and we'll simply solve it. So minus will become plus 1, and this comes as t minus ts plus s minus st plus 1 minus t minus s plus st. So we'll see t and minus t will cancel, s and minus s will cancel, and minus ts and plus st will cancel. So what we get, that is 1 upon 1 minus st, that is ts, and this can be written as 1 minus ts to the power minus 1. So we had seen that 1 minus t to the power 1 minus ts to the power minus 1 was our obtained expression. Now 1 minus x to the power minus 1 is 1 plus x square plus x cube. This is by binomial theorem. So we'll solve it or expand it by binomial theorem. We'll get 1 plus ts square plus ts cube plus dot 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 plus ts to the power n, and so on. So this can be written as 1 plus ts plus t square s square plus t cube s cube up to tn sn, and so on. So what we had solved, that summation mn equal to 0 to infinity integration 0 to infinity to the power minus x ln x into lmx tn sn dx is equals to what we have obtained, 1 plus ts plus t square s square plus t cube s cube up to tn sn, and so on. Now we'll compare the both sides of this infinite series, and what we'll see, that the coefficient of tn and sm is 0 if m is not equal to n. In all the cases, if m is not equal to n, that is if m is 1 and s is 2, n is 2, then we see that there is no such terms, that is the coefficient is 0, and 1 if m is equal to n. That is when the powers of t and s are equal, then the coefficient is always 1. For power 1, that is coefficient is 1. When power is 2, then also the coefficient is 2, and when power is 3, then coefficient is of both the terms. When power is 3, then the coefficient of t and sm is 1. So we see that the integration 0 to infinity to the power minus x ln x lmx dx equal to 0 if m is not equal to n, and 1 is if m is equal to n. Thank you.